A collision with a meteorite the size of Earth would be an event of cosmic proportions, one that is difficult to fully comprehend given the scale and the catastrophic consequences it would entail. The impact would release an unimaginable amount of energy, vastly more than any event the Earth has experienced in its known history. Firstly, the immediate effect of the impact would be the release of energy on a scale equivalent to billions of nuclear bombs exploding simultaneously. This would generate an intense shockwave, vaporizing the meteorite and a significant portion of the Earth's crust upon impact. The energy release would be so immense that it could potentially obliterate the Earth's surface, melting rocks and creating a vast crater that spans thousands of kilometers in diameter, if not entirely shattering the planet. The environmental consequences would be catastrophic and global. The impact would throw up an enormous amount of debris into the atmosphere, blocking out sunlight and leading to a dramatic cooling of the planet, a nuclear winter scenario, but on a much larger scale. This would halt photosynthesis, leading to the collapse of ecosystems and the extinction of most, if not all, life forms. Moreover, the impact would cause massive earthquakes and volcanic eruptions far beyond the scale of any previously recorded, potentially altering the Earth's tectonic dynamics. The energy release might even be sufficient to shift the Earth's orbit or its axial tilt, drastically changing the global climate and potentially making the planet uninhabitable. The aftermath of such an impact would also see the ejection of debris from the Earth into space, which could impact other bodies in the solar system. The collision could create a debris ring around the Earth or even send shockwaves through the solar system, affecting other planets and possibly altering their orbits. The survival of any living creature in the aftermath of a meteorite the size of Earth impacting our planet is extremely unlikely due to the scale and severity of the environmental and geological disruptions that would occur. However, if we consider the resilience of life in extreme conditions, a few scenarios could be imagined where some forms of life might have a slim chance of surviving, albeit in drastically altered circumstances. The most likely survivors of such a cataclysmic event would be extremophiles, microorganisms that thrive in extreme environments. These could include bacteria and archaea living deep underground or in the Earth's crust, in environments completely isolated from the surface. These organisms can survive high pressures, temperatures, and radiation levels that would be lethal to most other forms of life. Their ecosystems are often chemosynthetic, relying on chemical energy from the Earth's interior rather than sunlight, which would be blocked out by debris thrown into the atmosphere by the impact. Deep ocean ecosystems, especially those around hydrothermal vents, might also offer a refuge for life. These environments are based on chemosynthesis, similar to deep underground ecosystems. The organisms here are adapted to high pressure and complete darkness. However, the impact's effects on the planet's geology and oceans would likely alter these habitats significantly. The initial thermal shock and subsequent changes in ocean chemistry might render these refugees uninhabitable for even the hardiest of current vent-dwelling species. Tardigrades, or water bears, are microscopic animals known for their incredible resilience. They can survive extreme temperatures, pressures, dehydration, and radiation. In some scenarios, tardigrades in a dormant state might survive the initial impact and extreme conditions following it. However, the long-term survival of tardigrades would depend on the eventual return of conditions that could support their rehydration and reproduction, which seems unlikely given the scale of destruction expected. In a highly theoretical scenario, humans or other life forms could survive in specially designed bunkers or habitats that are self-sufficient and capable of withstanding extreme shocks and temperatures. These would need to be engineered to support life for extended periods without any input from the outside world. The feasibility of constructing such shelters in anticipation of such an event, however, borders on science fiction. While the resilience of life is remarkable, the scale of destruction from a meteorite the size of Earth impacting our planet would likely be too great for any multicellular life forms to survive. The chances of any life enduring through such an event would be confined to microscopic organisms in isolated, extreme environments. And even then, their long-term survival would be uncertain. This scenario underlines the precarious nature of life in the face of cosmic-scale events. In summary, A meteorite the size of the Earth colliding with our planet would likely mean the end of the Earth as we know it. The scale of destruction would be so complete that it's challenging to predict the exact outcomes, but they would undoubtedly be devastating to the planet and catastrophic for all forms of life. This hypothetical scenario underscores the incredible force and energy involved in cosmic events and the fragile nature of our existence in the vast universe.